Right, so I want you to write this down. Exponents, as I said, right, so as I've said already, integer exponents basically means that the exponent itself will be an integer, right? And we said that the exponent will look like one of the following. So it'll be one of the following numbers here, right? That's firstly, the first thing that you need to remember. The second thing that you need to remember is that we use exponents to express really large numbers or really small numbers, right? So for really large numbers or really small numbers, we can use exponents to express them. And that's basically what when we start talking about scientific notation. But I'll talk about that maybe at the end of the video, because we have to discuss some of the exponential rules so that you have some foundation. Okay? So basically, what's the basic idea of exponents? You see, if we are multiplying the same number numerous of times, we will make use of what we call exponential notation. Right, so let's say that you have 2 times 2 times 2 times 2 times 2. So we've got 2 5 times. Instead of writing it in this expanded form, we can compress all of this into 2 to the power of 5. What this 2 here at the bottom here, what we call the base, is basically the number that is being repeated. And what this number here at the 5, the exponent, is basically the number that tells you how many times the base is being repeated. So this is a number that is being repeated. This number here, the exponent, tells you how many times the base is being repeated. And that's the basic structure of the exponential notation. That's the basic structure of exponents. Nothing more, nothing less. Okay? So that's basically what we need to understand there. Right, so that's number 1. So for number 1, we basically understand integer exponents. And number 2, you basically understand your exponential notation. Let's talk about number 3, the placement of the negative. With the placement of the negative, you need to remember something. You see, minus 4 squared, and this is more applicable when we are dealing with even roots. I'll tell you why. Minus 4 squared and minus 4 squared will give you 2 different answers. In this case, you get minus 16, and in this case, you get 16. Right, let me explain why. You see here, it's effectively minus 1 times 4 squared, which is equal to minus 1 times 16, which is equal to minus 16. Here, it is minus 4 squared. So both the minus 1 is squared and the 4 is squared. That is why we get 16. Do you understand that? Or we're saying it's minus 4 times minus 4. Right? There's no minus 1 that stands on its own. The square is applied to both the minus 1 and the 4. Do you see that? So we're saying minus times a minus is a plus. 4 times 4 is 16. This is what I mean by the placement of the negative. Now, when you're dealing with, so this, like I said, more applicable for even powers. Why? Because, and this will lead us to the next thing that we need to talk about. When you multiply an even number of negatives, see, even number of negatives will give you a positive. So multiplying even number of negatives will give you a positive. And then multiplying odd number of negatives will give you a negative. So here, you see with the even, this is why we have to create a case here for the even. Because in some instances, you could get the negative, even though that the power is even. Like the first case here. I could get a negative answer because the square is not applied to the negative. It's applied to only the 4, not the negative. So we're not saying we're multiplying an even number of negatives. We're multiplying by negative 1 here. In this case here, now I'm saying I'm multiplying by an even number of negatives because the negative is repeated 2 times. So that's the reason why we get a positive. However, with a odd number, so if the power is an odd number, right? If the power is an odd number, for example, if I said minus 3 cubed, or I said minus 3 cubed, both will give you minus 27. Both. Because it does not matter. Odd number of negatives will always give you a negative. Understood? So again, in this case here, we do have minus 3 times minus 3 times minus 3. In this case, we have minus 1 times 3 cubed. Right? So we still get a negative in either cases. But with the even number of negatives or with an even power, we have to be but with an even power, we have to be very careful where the negative is placed. So always keep this even. When you're given an even power, always keep this in mind. That's like something that you need. That's like a warning signal. You need to be very careful with where the negative is placed. Right, and I even showed you exactly how you should think about it logically. So it's not something that you should commit to memory. You should understand it, basically understand it by just using logic. Okay. Okay. Now, this is what I want you to write. What does it mean to square root a number or cube root a number? Right? What does it mean to square root a number or cube root a number? Okay. So firstly, let's do this. I want you to write this as a heading, right?